All right, so chapter 6 is all on systems of equations and inequalities. All right, so back to the very beginning, we started with our systems of equations. So we had three different ways to solve these. One was solved by graphing, two was solved by substitution, three was solved by elimination. Okay, so the first thing, just a couple definitions. System of equations, just two or more equations have the same solution. And for something to be a solution, it has to satisfy every equation in the system. Something matches, it fits in for one of them, but not the rest of them, it doesn't work. It has to fit for all of them. All right, to solve by graphing, well, when you graph the lines, there's going to be three different possibilities. One is they cross, that's the most common one, that's probably 90% of the time. If they lay on top of each other, then they're infinite solutions, and if they're parallel, they're no solution. Most often, you're going to get the one on the left, the one solution. All right, and wherever that point is that they cross, that's going to be your solution for that. That x and y coordinate is going to be your x and y value for that solution. All right, so for instance, if we have this one, just graph the first one, 2x plus 4. So I'm at plus 4. Slope is up 2 over 1. Okay, I'm just going to continue a little more. That'll be there. Okay, so it looks something like this. Second one is x plus 2. So here, 1 over 1. All right, so it looks like they intersect. They're going to intersect right here. That would be the point, negative 2, 0. That's your solution to the system. This is the first problem.
Yeah.
Okay, so we graphed both of those where those two crossed at one point was negative 2, 0. Therefore, negative 2, 0 would be my solution to that. Okay, that was solved by graphing. Sometimes you might have to solve them. So for instance, in this one here, we'd have to solve for y so we know how to graph it. All right, otherwise, it's pretty straightforward. Graph the two lines where they cross it, they cross. If you want to solve by substitution, big thing with substitution, you want to get one variable all by itself and then plug that into the other equation. So get one variable by itself, box it, plug that into the other equation for that variable. Then you'll simplify, you'll get first answer, take that, put it back into the box. So in this case here, we have one. I'm going to skip ahead one. I'm going to go to this one. All right, so let's do this one for substitution. We want to get one variable all by itself. So I'm looking at it. I have an x and y in the first one that are both kind of by themselves, and the second one I have a y that's kind of by itself. So let's get that x in the first one by itself. X minus y equals 2. Okay, so to get x by itself, I'm going to add the y across. X equals 2 plus y. Now I'm going to box that up. I'm going to put that into the other equation, which is 2x plus y equals 1, and I'm going to put it in for x. So now I have 2 plus y equals 1. Distribute. So I get 4 plus 2y plus y equals 1. Combine like terms, I have 3y. I'm also going to subtract this 4 over. So I have 3y equals negative 3. So y is negative 1. That's my first answer. Then put it back to the box. X equals 2 plus a negative 1. So x equals 1. So x is 1, y is negative 1. That's how you do substitution. Next one, elimination. Big thing with elimination. This is the third way we were taught how to solve systems of equations. You want to get one variable the same in both equations, one positive, one negative, then turn it into a giant addition problem. Okay, from there you're going to add the two equations together, and if you have it that one variable is the same, one positive, one negative, then that one's going to add out. So let's go ahead and go to this one. This is a little tougher. All right, so in this one, I have an x is a 9, x is a 3, y is a 5, and y is a 1. Okay, so in this case, I'm going to have to multiply something by one of the two equations to get one variable same, one positive, one negative. I see that 3 and the 9 pretty quickly, and that kind of perks me up to an idea here. I can multiply the second equation by negative 3. and then get my x's to cancel out, right? All right, so let's multiply the second equation by -3. If I do it to 1, I have to do it to all of them. So now it's going to give me 9x minus 3y -12. Remember, multiply that right side of the equation by the number as well. A lot of people, when they make a mistake, they would get 9x minus 3y equals 4. Okay, make sure you multiply that right side by it as well. Yes. No, you don't get to choose the equations. There's going to be some that you choose, some that you don't. There will be one or two that say use elimination, one or two that say use substitution, and the rest will be up to you.
Is there a lot of word problems?
Not a lot, but probably 4 or 5. Okay, now I'm ready to go because I have my x's lined up. All right, this is going to cancel out. Straight down, I have 2y equals -13. Divide both sides by 2. So y is going to be -6.5. There's the first one. Take it, plug it back into one of the originals. I'm going to go with the second equation. So -3x plus -6.5 equals 4. So I have to add 6.5 over. So I have -3x equals 10.5. Divide both sides by -3. X is going to be -3.5. So there's my solution. X is -3.5. Y is -6.5. Questions? All right, next set.
Morning, everybody.
More. Do you need something? Just poking his head in. Okay. All right, then there is some special cases. Special cases is if you get down and your variables cancel out. If you have a false statement like 2 is equal to 4, then that's going to be no solution. If you have something that says like 3 equals 3, that's a true solution, then that would be infinite, and you could stop right there. All right, so then systems of linear equations and problem solving. This is where we got into our word problems. So for our word problems, we looked at 4 or 5 different types. Let's just kind of talk through those real quick. The first type we had was just unknown numbers. It's one where you break down the sentences. So for instance, the first number is 4 less. I see 4 less, that means -4. Then the second number, okay? So we say first number is x, second number is y. So we're looking at x equals y minus 4. That's the first one. Second one, 4 times. So I need something where I multiply by 4. The first number, well, we just found that the first number was x. Is 6 more than, we saw is, that means equals. 6 more is plus 6 than the second, then twice the second. So that's 2 times our second number, which is y. It's going to give me 4x equals 2y plus 6. And then for that, you could solve it however you'd like. That one probably looks like substitution to me. As soon as I see this and this, I would substitute that one. Just break those one down word by word. We've been doing those since day 1. All right, here we go, break even. So if you have a break even, that's going to be one where you want to figure out, where your income and your expenses are going to be the same. Okay. And this one here, this one's a pretty simple one. Okay, we have costs and we have income. So our first equation, we'll have a cost and then we'll have a profit. Our cost, we got $5.50 for every hat. So we have 550x plus what? Plus $1,400. That was a one-time deal. Okay, that's my cost, and then I sell them for $12.50. So that's my profit. So then I have 1250x. There would be my 2 equations. Then you could solve them, eliminate substitution. That one looks like a substitution one to me. Okay, so typically break even, substitution is going to be your best bet. Okay. Next type we had was Our coin problem. Our coin problem is probably the most common one, I'm gonna say. All right, because this is the one that goes for like food at the deli or the concession stand and that type of stuff. This is if you have two items that have value. All right, so two items with value, whether they have a price or whatever it might be. Okay, and in this case, you're gonna need two equations. Your first one is going to be the number of items. Second one is going to be the value of it. So in this case, we're just talking about coins. We have pennies and quarters. We have 27 coins total. So in that case, x plus y equals 27. Second one, what's the value of them? Well, the value is going to be how much they're worth. A penny's worth 1 cent, quarter's worth 25 cents, and total we have $4.35. Okay, that would be the same if you were talking about cheeseburgers and hot dogs at the food stand. Whatever the price of one is, whatever the price of the other one is, however much you made total, and then however many you sold. Okay? Again, it doesn't have to necessarily be a coin to be a coin problem. So this is one right here. We did this one. Booster Club runs a food stand at the home games. Sell hamburgers for $4, hot dogs for $1.50. First quarter of the game, they sold 31 items and made $94. How many of each did they sell? All right, so value items. How many items did they sell? 31. First equation, x plus y equals 31. Okay, now, how much is hamburger? $4. How much is a hot dog? $1.50. How much do we make? There you go. There's your two equations. Substitution or elimination. I'd probably go. I'd probably make these all whole numbers first. And then it wouldn't really matter. You multiply the first one by 400. All right, or
50 gets 150, or is that 150?
okay. So this one, either one of these, I'd probably use substitution myself because I could get this x by itself and just take that y over real quick. But I like substitution better as well. All right, so that one could go either way. All right, when the current problems. So I like to put these in terms of wind problems more so often than not. The current with the river goes exactly the same way though. So for these, the setup is this. Your ground speed is equal to your airspeed plus or minus your wind speed. Okay? So your ground speed is like your overall speed at the end. Airspeed is how fast the plane is flying. Wind speed is either pushing for or against it. Okay? We're imagining it's either it's blowing straight in the face or straight from behind. You get ones where it's blowing across winds later on in your math career. All right. So in this one here, it says the ground speed one way is 495, ground speed the other way is 550. It's the exact same trip. So these two equations, I'm going to have x plus y and x minus y because I was given the ground speed, right, Cam? Okay. So obviously, when I'm adding, it's going to be the faster of the two, right? Faster of the two is the 550. So I have 550 here. Here I have 495. Then I would do elimination on that one. I mean, that's set up for it right away. You don't even have to multiply, and your y's are going to cancel out.
Wait, so that's all it is?
You have to solve it.
Oh, yeah, I know, but like, how do you solve that?
Elimination, I just said.
Yeah.
Your y's
so
cancel.
you match your y, then
You get 2x equals 1,000 something. You don't get ground speed? Do I have anyone here? All right, pretend that's not there. You want one where you're not given ground speed? Is that what you're asking? All right, current in the river is 2 miles per hour. Let's get 3 miles per hour. And you're paddling 20 miles. 20 miles up, 20 miles down. Okay? So, you know the current is 3 miles per hour, and you're going the same distance up and down. How much more do I have to give you? This takes 4 hours. So it takes 4 hours up and then 5 hours back. Okay? So in this case, that's not.
Are we
We
gonna
don't
have a
even need
problem
this.
like this?
You might need one like this, so we'll use just what I gave you there. Okay? You paddle 20 miles up and down a river. It takes you 4 hours to go up, takes you 5 hours to come back. Okay? Now, in this case, I'm going to still have my x plus y and x minus y, correct?
Yeah.
But do I have the speed? As of now, no, do I? What I need to do, I need to find that speed. Okay? So in this case, 20 miles in 4 hours, 20 miles in 5 hours. This one here is going to be 20 over 4, which is what? 5 miles per hour. Second one is going to be 20 over 5, which is going to be what? 4. So that's my ground speed, right? So going upstream, or going downstream when it's helping me, I'm going 5 miles per hour. Going upstream when it's against me, I'm going to be at 4. All right with that?
Put the lower one on the bottom.
Lower one goes with the minus. Straight down. 2x equals 9, so x is 4.5. Plug it back in. I get 4.5 plus y equals 5. Subtract it over, y is going to be 0.5.
What's 4.5 equal to?
That's the speed of your boat. This is the current. Current, boat speed. This will be very similar to one on your test, where you have to do this first. Okay.
Didn't you give us a couple problems to try?
No, you had it on your homework. Okay. Mixtures. This is probably the toughest one, I would say, because there's that one extra step at the end. Okay, so a chemist is working on a COVID vaccine. Needs to mix a 10% sodium solution with a 60% sodium. Needs 50 milliliters of 30%. How many milliliters is it should be mixed? So this is very similar to a coin problem. All right, we have our total amount that we need, but we also have values to it. How many milliliters do we want total? 50. Okay. First equation, x plus y equals 50. Take the first one, add the second one, we get 50 milliliters. That's what we're going for. Now, the second one, we have to apply the percentages to it. So we have 10% of the first one. It's a 10% solution. Second one is a 60%. Now, you don't just put 30% at the end, do you? This is that one extra step. I need to find what 30% of 50 is. So I take 50 times 30%. What do I get? 15. That is what that one's going to be equal to, because it's 30% of 50. Okay, and then you would just solve that guy. Okay, I'd probably use substitution there, yeah. I'd probably multiply this guy by 100 first,
Just
and then use
multiply by
substitution.
10.
Yeah, you can multiply them by 10. All right. These are just some more examples we already did. So then linear inequalities. Linear inequalities where we brought the greater than, less than back into the fold. Okay, it was the same thing as before. We want stuff to be true. All right, and all we did was plug the numbers in. If I had these different numbers, I plugged in a 1 and a 2. This is my x, this is my y. So in this case, I have 2 is greater than 1 minus 3. 2 is greater than 1 minus 3 is negative 2. Is that true? Yes. So this would be a solution. As long as it makes it true, it is a solution. All right, we did that. Then we talked about graphing these. Graphing these, if it's greater than or less than, it's a dotted line. If it has an equal sign under the greater than or less than sign, then it's going to be a solid line. If it's graders, you're going to shade above. Less than, you're going to shade below. Okay, so here x is greater than or equal to x minus 2. Do it exactly the same as before. At negative 2, my slope is up 1 over 1. Here's my line. It's greater than, so I would shade above. Second one, less than, negative 1/2 x plus 3. There's no line underneath, so this can be dotted. So I'm going to be at positive 3, down 1 over 2. This would be a dotted line. It's less than, so I'm going to shade below. Then we went to inequalities for systems. All you have to do there is put 2 on the same one, just like we did in our warm-up today. Put 2 on the same one, and the overlap is what our answer is. So here, 2x minus 3, and minus 3, up 2 over 1. It's going to be a dotted line here, and I'm going to shade below. You're going to have to show a graph. All right, then greater than negative 2x plus 2. Here, down 2 over 1. Looks like this. And that one we're greater than, so we're shading above it. So then therefore, this section right there would be my overlap. That's my solution. So in this case, 3, 0, is that a solution? It would be. How about 2, 5? You don't have to put a box around it, no. Try to make sure you know that I know which section you're talking about. You know what I mean? I mean, if it all looks like this, then we're gonna have some issues. All right. I would go through, like, say you got it like this, okay? We'll even take that triangle away. Just listen. If you get it like this, do you see where the overlap section is? I would go through and shade it again. Make it pretty dark in that section. You see what I mean? All right. Now, again, make sure I can see if it's dotted lines or solid lines and that kind of stuff. So if you're not perfectly on it, that's fine. All right.
I never realized that I needed to do dotted line until I do it. So I have a solid line and then I'll put the dot beside it.
Okay.
It makes sense to me, so that's all that matters.
I just want to see a dotted line. Okay. All right. Questions on that stuff? That was the whole chapter.